Okay, welcome back to the ChemDoctor, and this is the fourth or so video that I've done this morning on limiting reactants, and we're going to work an example now that's set up just a little bit different than the other ones. Advanced students will notice that this is a precipitation reaction. We have a solution of barium hydroxide where the barium and the hydroxide are fully dissolved, and to that we're going to add some sodium sulfate. When we do that, the sulfate anion combines with the barium cation to form barium sulfate, an insoluble solid that precipitates to the bottom of the beaker, as I'm showing over here in this picture. And the spectator ion, sodium hydroxide, remains in solution over the surface or above the solid precipitate. So let's take a look at how this limiting reactant problem is different. You can see that in the case of the barium hydroxide, we're given a volume and we're given a molarity, whereas with the sodium sulfate, we're given a mass amount. Now, the way you solve this problem is exactly the same way that we did previous ones, where the goal initially is going to be to find the moles of the barium hydroxide, the moles of the sodium sulfate, solve for the product using each one independently. Whichever of these two reactants produces the least amount of the product, that is the limiting reactant. The catch here is that we're going to have a slightly different kind of calculation to do for the two reactants. In the case of the barium hydroxide, we have a volume and a molarity, so we're going to need to find the moles of the barium hydroxide, and the way we're going to do that is by first converting the volume to liters. All right, and remember that in 1 liter there are 1,000 mLs. So 10 milliliters of barium hydroxide is actually 0.01 liters. Now we take the volume that we get, and remember that molarity is units of moles per liter. So to find the moles of barium hydroxide, we're going to take our volume, which is 0.01 liters, and we're going to multiply that times the moles per liter of the barium hydroxide. All right, and what we get is 0.001 moles of the barium hydroxide material. All right, now in the case of the sodium sulfate, we set this one up like we did in the previous examples, where we have 1 gram of Na2SO4, all right, and we're going to multiply this times 1 over its molar mass, all right, and let's see here, for brevity's sake, I'm going to go ahead and write the molar masses of these various things in above their compound formulas. So the molar mass for for the sodium sulfate is 142, and we're going to need barium sulfate too. This one's 233. All right, 233.4. All right, now, so we need to convert the sodium sulfate to moles. So it's going to be 1 gram Na2SO4 times 1 mole over 142 grams. All right, and we see the grams is going to cancel with the grams, and we're going to end up with 0.007 moles of Na2SO4. And I'm going to move this a little bit so that we're working one over the top of the other. We have 0.001 moles of barium hydroxide. Now, you'll notice if you look at the coefficients in this balanced equation that we can actually decide on the limiting reactant right now, because the coefficients are all 1 to 1 to 1. And you can see the barium hydroxide is present in smaller amounts than the sodium sulfate, and this is going to turn out to be our limiting reactant. But I'm going to hold to the method that I've been teaching you, because I think it's important for you to see that this one is going to produce less barium sulfate, and we have to do the calculation anyway in order to calculate the mass of barium sulfate that we produce in the reaction, the actual theoretical yield of the BaSO4. So we're solving for the BaSO4, so 1 BaSO4 goes in the top of each respective mole ratio. All right, and then in the bottom we put what we want canceled. So here we have BaOH2, and in this one it's 1, and then sodium sulfate. So you can see that we're going to produce 0.001 mole of the barium sulfate by the barium hydroxide, and the sodium sulfate, if we were utilizing that reactant solely on its own, we'd be producing 0.007 moles of Na2SO4. So we produce less amount of BaSO4 utilizing the barium hydroxide. So I'm going to come back over here and circle this and label it as my limiting reactant, and therefore the sodium sulfate is the thing that's in excess. Alright, so now we can find the mass of our precipitate by multiplying directly times the molar mass of the barium sulfate, which is 233.4 grams per mole. And the outcome of this, I'm going to put it down here, is going to be 0.2334 grams of BaSO4 precipitate formed. And remember, this is your theoretical yield. All right, and now we can find the mass of the remaining reactant. So this is our excess. Remember that to find the mass of the remaining reactant, you first need to figure out how much of the other reactant actually was combined with the limiting reactant. So we're going to take our limiting reactant and we're going to pull it down. So we're going to have 0.001 moles of BaOH2, and we're going to ask the question, how much of the sodium sulfate had to react with this? So we're going to multiply by our mole ratio, which is going to be Na2SO4 over BaOH2. Ratio is 1 to 1 again, so we're going to utilize 0.001 moles of the Na2SO4. Now, since we're in grams for the excess, what I'm going to do is go ahead and convert this value here into mass. All right, so we're going to be multiplying this number by the molar mass of the Na2SO4, which is 142 grams per mole. All right, so the mass of Na2SO4 that was reacted is 0.142 grams. Okay, now I'm getting ahead of myself. Let's make sure to label some things. So this is moles, Na2SO4 used by the barium hydroxide. All right, and this is mass of Na2SO4 used. All right, so to find the mass of the remaining, we're going to take 1 gram of Na2SO4, and this is the excess. We're going to subtract from it the mass of the Na2SO4 that was used up, and this is going to equal the mass remaining, which is going to be 0.858 grams of Na2SO4 that remains unreacted. All right, remains unreacted. Okay, and with that I'm going to go ahead and close the video.